Here we go to ICRA to continue with our integration classes, and we were studying last time the trigonometry terms, and in this particular class we will study integration of sine to power mx and cos to power nx. So yes student J. So what do you mean by m and n here? Okay, I'm going to tell you that m and n here are integers or rational numbers, but not all set of rational numbers, only the standard form. So I'll show you how we do for different particular cases. Okay, so let's move. I have integration of sin to power m and cos to power nx, and I'll show you directly by the examples. For example, if I have integration of sin to power 3x and cos square x, so one of them is odd and another is even. So what should I do? If I have one odd and another even, does anybody have an idea how to do that? Yes, student E. Sir, if I have odd and even, then I can substitute one as t so that the other becomes dt, because I have both sin x cos x. Yeah, exactly, that's what you are doing is correct. But which one I should substitute as t? Sin or cos? Which one is easier? So the which one is odd. Sin to power 3, it is odd. So if I put cos to t, cos equal to t, then one of the sin will become dt. Exactly. This is how we will do. Actually, I will split this odd into two parts. This sin cube as sin square, and the other part is sin of x. So that if I put cos of x is equal to dt, if I put cos of x equal to dt, then minus sin x dx becomes dt. So this whole thing, which I have split into two parts because it was odd, so this minus sin x dx becomes my dt. So what will happen? This cos of x is t, so this will become my t square. And what about my sin square x? I will convert into cos square x. So this is my 1 minus cos square x, so I will have 1 minus t square. Okay, so this becomes very easy. I have 1 minus t square, and this cos square is t square, and this thing is very simplified. This becomes polynomial, and the integration of this is very easy. T to the power 5 on 5 minus t cube upon 3 plus constant. What about if I have other way around? I have cos to power odd. So it is the same thing. What I will do, I will put sin of x is equal to t, so that my cos of x dx becomes dt, and I will split this. I have split this whole power odd into two parts, cos square, and the other one is cos of x. So this cos of x dx becomes my dt with my substitution sin of x is equal to t. Okay, so this thing is very easy. Again, it becomes polynomial, and the integration of this is very easy. Now what about if I have both powers odd? So whenever I have both powers odd, I have an option to substitute one of them as t. But you will notice that one substitution becomes very easy and the other substitution becomes very complicated. So I will make a substitution where things becomes very easy, and you will see that if I put sin of x is equal to t, okay, then my cos x dx becomes dt. So this thing is very easy. You will see that how you will appreciate this particular thing, substitution. I split this thing into two parts. This cos power odd is one is this and other is this. So if I put sin of x is equal to t, then cos x dx becomes dt. So what is the beauty here? Since my sin of x is equal to t, so this whole thing becomes t to the power 17. This is the wonderful thing. And this cos square x is small, so this becomes 1 minus sin square x is 1 minus t square, and this thing becomes dt. And you see that how easy it becomes. I got a polynomial only of two terms. This is my one term and this is my second term. But suppose if I put cos of x t, then the things would become very complicated. So cos of x is t is not a good substitution. Let's check. Suppose if I put cos of x is t, then I have to split this sin of x into two parts, sin to the power 16 and sin to the power x. Now if I put cos of x t, then I have minus sin x dx dt. So this thing, okay, this thing will become dt, no problem. Cos of x is t, so this thing will become dt cube. But what about this? I have to convert this sin into cos, and then I simplify. So what will this happen? Sin square whole to power 8. So I will have 1 minus t square whole to power 8. So I will have a polynomial of 9 terms. then t cube. So this is very complicated. I will have 9 terms. Although if I solve, I get the same answer as this. But see, I have to integrate, I have to use binomial theorem to expand it because I have power 8, and then if I integrate, it will be very lengthy process. Okay, so what is the trick here? Whichever is the higher power, I have sine to power 17, this is the higher power, so put sine of x is equal to t. This is the best substitution. So this whole thing become t to power 17. This whole thing become t to power 17. Okay, I hope you understood. Now we move where I have both powers even. So the odd, there is no odd power, so there no substitution will work here. So what I have to do here, I have to reduce the power using trigonometry. So I use trigonometry to reduce the power, and there are many ways. One of the ways is this. You can choose any way which comes to your mind. What I have done here, I put sin square x as sin square x whole square. Then I make them linear because I know that sin square x is 1 minus cos 2x by 2, and my cos square x is 1 plus cos 2x by 2. So I become, these two becomes linear. Then I can simplify further, and I split this again into 2 parts because I am visualizing some way. Maybe some other formula come to your mind. So whatever way come to your mind, use it to make it linear. And what I am doing here, I split it 2 parts because this thing, this is my suppose a minus b, this is my a minus b, and this is my a plus b. So what I will have here, a square plus b square. So this is my a minus b and a plus b. I get here a square minus b square. So I will have 1 minus cos square 2x, which will simplify to sin square 2x, and further simplify to 2 terms. So I can split the integration into 2 parts. This is one of my integration, I do it separately, and this another integration, I do it separately. So I will have I1 plus I2. I have 2 integrations. Now I do this thing separately. My I1 is integration of sin square 2x. Again, I have even power. I don't have any odd power. So whenever I have even power, again I use trigonometry to reduce the power, and my sin square is what? 1 minus cos 4x by 2. So this is linear, and the integration of this is easy. 1 becomes x, and cos to power 4x becomes sin to power 4x upon 4. Okay, now let's see I2. In I2, I have 1 power even and another power odd. This power is 1. So I have 1 even and 1 odd. So what I will do, I will put sin 2x as t, because this is the way we do, and the cos 2x becomes dx becomes dt. So what I will have here, this thing becomes dt, cos 2x dx becomes dt, and this is my sin square 2x. So this integration becomes minus 1 by 8, 1 by 2 t square, and the integration is very easy. Okay. Now we move further where I have a special form where m plus n is a negative even integer. M plus n is negative even integer. Then I have a special method for this. Okay. I will take an example, and here my m plus n is minus 2 is a negative even integer. So I will use a special example. Okay, one thing you have to note here, that I don't necessarily have to have this m and n in the p by q form. Even though my m and n are integers, one can be negative, so that my m plus n is negative even integer. Whether my m is p by q form or not, n is p by q form or not, but if my m plus is negative integer, suppose my m is minus 4, this is my minus 4, and my n is 2, so m plus n is minus 2 is negative integer. So even for that case also, this method will work. And what is the method? You will see that it is very interesting to note that this will always reduce to the integration of function of tan of x sec square x form. I will have function of tan of x and sec square form. This is very interesting thing to see, that always this will reduce to this form, and here also it will reduce to this form. And I know that this will reduce to this form, so I will directly apply this method. I will multiply and divide by sec square x, because I know that this will become tan of x. So this will be my sec square x dx. Okay, and this whole thing, I know that whole thing will become function of tan of x, and this sec square x dx will be as it is. See how it becomes like this. I keep this sec square x as it is, I don't touch this, and I simplify this. You check yourself that if you simplify this, this will become sin to power 3 by 2 upon cos to power 3 by 2, which is actually nothing but 10 to power 3 by 2. And the substitution for this is 10x is t, so sec square x dx becomes dt. So it becomes t to the power 3 by 2 dt, and the integration of this is very easy. It's 2 by 5, 10 to the power 5x, 5 by 2x plus c. So remember, whenever you have m plus n is negative even integer, this will always reduce to the form function of 10x sec square x dx. And the substitution for this will be 10 of x is equal to t. This is the substitution for this. So remember, we have studied m plus m and n of different forms, where one of them is odd and another is even, both are even, and if they are rational or the sum is m plus n is negative even integer, then we reduce to this form. Okay, I hope you have understood. So with this we end our this particular session, where I have integrated sin to the power m and cos to the power n. In the next class we will study 10 to the power m and sec to the power n. Okay, see you then. Thank you.